Today we can start a new chapter, that is chapter 4, quadratic equations. You have studied the chapter polynomials. Do you remember that? Polynomials. Some different types of polynomials you have studied. Linear polynomial, quadratic polynomial, cubic polynomial, etc. Can you say what is a linear polynomial? A polynomial with a degree 1. A polynomial with a degree 1. That is a linear polynomial. What is a quadratic polynomial? A polynomial with a degree 2. Then what do you mean by degree of the polynomial? Degree of the polynomial means the highest power of the variable used in that polynomial. Highest power of the variable with a non-zero coefficient. Okay. So here it is. Quadratic equations we are starting means a quadratic polynomial. If you are equating to 0, that will become a quadratic equation. Equation means equality we are using. Okay, equality symbol. So a quadratic equation is a quadratic polynomial equating to 0. Now, can you say the standard form of a linear polynomial? Linear polynomial, what's the standard form? Can you say? It is ax plus b. Ax plus b. X, the variable used is x. A and b are real numbers. A and b are real numbers. X is the variable used. And the power of the variable x, that is 1. X only means x raised to 1 now. So, linear polynomial, the standard form is ax plus b, where a not equal to 0. A and b are real numbers and a not equal to 0. Now, quadratic polynomial. Can you say the general form or standard form? Quadratic polynomial standard form, that is ax square plus bx plus c, where a, b and c are real numbers and also the power of the variable x. See that? X square. Ax square. So, 2. The power of the variable, highest power of the variable is 2. Means it is a standard form. So, here a not equal to 0. The condition is a not equal to 0. That is, the standard form of a quadratic polynomial is ax square, where a, b and c are real numbers and a not equal to 0. So, if quadratic polynomial equating to 0, that is ax square plus bx plus c equal to 0. That is the standard form or general form of a quadratic equation. That's the first idea we need to study here. Quadratic equation, that is quadratic polynomial equating to 0. And the standard form is ax square plus bx plus c equal to 0, where a, b, c are real numbers and a not equal to 0. And what is a? The coefficient of x square. What is b? The coefficient of x. And what is c? It is the constant term. A not equal to 0, that's a condition. Okay, so here you can see standard form of a quadratic equation. Ax square plus bx plus c equal to 0, a not equal to 0, then a, b, c are real numbers. Okay, so we can say that it is p of x equal to 0, where p of x is a quadratic polynomial. Here the variable is x. Okay, quadratic polynomial equating to 0. Now we can see some examples. Can you say some examples? Yes, easily we can say. So here it is. I'll give you one example. 3x square plus 2x plus 1. Okay, it's a quadratic polynomial that equating to 0. Understand? So here it is. The value of a equal to 3. What is b? 2. And c, the constant term is 1. Okay. Now the second example. This is the first example. Second one. Not 3. Another number we can select. 5x square minus 4 equal to 0. Whether it is a quadratic polynomial? 5x square minus 4? Yes. So equating to 0, it is a quadratic equation. Quadratic equation. See, what is a equal to? The coefficient of x square, that is 5. And what is b? The coefficient of x. b is the coefficient of x. That term is missing here. Means we can select it as 0. Now, what is c? The constant term? It is minus 4. See that negative sign. So, here it is negative Understand? Now we can see another example. That is negative 2x square. It's a third example. Okay. Negative 2x square plus 5x equal to 0. Whether it is a quadratic equation? Yes. How we can say it is x square term. So it is of the general form, standard form, ax square plus bx plus c equal to 0. Can you say what is the value of a? A equal to the coefficient of x square. X square, the coefficient is negative 2. Negative. What is b equal to? The coefficient of x. The numerical part of x. What is that? 5. And what is c? The constant term. So in this equation, the constant term is missing. Therefore, we can select it as 0. Okay. So a, b, c. These three coefficients, a cannot be 0. So other two. In this equation, c is 0. And the previous example, we have seen that b, the second term is missing. Okay, b equal to 0. Okay. So another example we can see 9x square equal to 0. Whether it is a quadratic equation? Yes. Or we can say this a is not equal to 0. So in this case a equal to 9, b equal to what? 0, c equal to that also 0. Can you understand? Okay. Now one question is there. Check whether it is a quadratic equation or not. Okay, that's the question. So question number 1, we can see that x plus 1 whole square equal to 2 into x minus 3. Suppose one equation is given like this. Equation equality is given here, left side and right side, LHS and RHS given. Okay. Now x plus 1 whole square. So you have studied some identities. Remember a plus b whole square, a minus b whole square and all. So here we can apply that. And here also we can apply some identities. A into b plus c, a into b plus a into c. Remember these identities? So I will give a plus b whole square. That is equal to what? A square plus 2ab plus b square. This identity you are applying in the left side. And for the RHS right side, here it is 2 into x minus 3. So for that the identity you can apply, that is a into b plus c. What is a into b plus c? You remember it is already studied. A into b plus a into c. Okay. So it is ab plus ac. So if these two identities you are applying here and expand. And our method is expanding left side and right side and taking all the terms to the left side. Taking all the terms to the left side. Then check whether it is of the form ax square plus bx plus c equal to 0 or not. That's our method. Okay. So here it is expanding. LHS we are expanding by applying the identity a plus b whole square. So here it is. See that LHS. X square plus 2ab means what? 2 into first term into second term. 2 into x into 1. So it is 2x plus 1 square it is 1 itself. That is equal to then a into b plus c. So 2 into x, 2 into 3. Here it is subtraction, that only the difference. So here apply 2 into x it is 2x minus 2 into 3, 6. Okay. So LHS expansion is here. RHS also we are expanding. Then the next step is taking all the terms to the left side. So here it is x square plus 2x plus 1. Left side we are writing like this. And taking these two terms to the left side. For that side change means sign change. Remember that? So 2x, here it is positive, that will become minus 2x. Here minus 6, that will change the sign, that is plus 6. That is equal to 0. So taking all the left side terms here, right side 2 terms are there, these 2 terms we are taking to the left side. Now we are simplifying this. Okay, so x square, first term is x square, any other x square term? No. And remember, like terms only we can simplify, add or subtract like terms only. So here it is x square. Next 2x and minus 2x. That we can cancel, no. Next 1 plus 6. What is that? Plus 7. That is equal to 0. So you got x square plus 7 equal to 0. Can you say the answer now? Whether it is a quadratic equation or not? Yes, it is a quadratic equation because here x square term is there. If x square term is present, the highest power of x is 2 here. Therefore, it is a quadratic equation. Understand? So, our answer is yes. Quadratic equation. It is a quadratic equation. The value of a equal to 1. Value of b 0. Value of c 7. Okay. So, such questions also you have to answer.